Anyone ever see sorry, where's the thing at? Oh, I do it here. That is actually a schematic of a microprocessor, um, circuit board, I guess. I don't know. Probably jack it up. So after 6 hours, think about what you said, and then I actually typed on the internet electric circuit diagram, and I wanted a key because I wanted to know what does each one represent, but I couldn't find one that had the key. What I found interesting, first of all, look at that. Somebody understands how to do this. Somebody knows what all this means and could be able to draw this out. Then I'm sure a machine, makes it happen. If you ever open up a computer, there's like just a bunch of metal like lines on the bottom right here where these lines are. That's where the I guess the electrical currents travel through. But all of them have a path, and they have a process that they take care of. Then if you zoom in on this, some of the symbols are different than others. Like one I circled right here. An electrician would know what these symbols mean. Like that one, that squiggly must mean something, and then these arrows obviously mean something. These little open slots that we see right here must mean something. And someone that is a professional electricity and electrical engineering, I'm sure this is what would be about all of this. They would know how to draw out these schematics. So I just thought it was interesting compared to what we're doing. There's that message we get all the time about a graph of where things go, and then what they actually do. So electrical engineering, no, this isn't going to be on the test, like I said in the beginning. I just thought it was interesting. Now to the boring notes. Yeah, it'll be fast if you just let me get through it. I don't know if they're boring. They're just more terms. Keeping it slow on this slow Thursday during homecoming week. Not really a big deal today. So really, it's just about terms. So basically, what I might think you would do is, well, I don't know. You could find your terms where they're at, but really just keep these first three terms readily available, so you're able to answer the questions. Then a couple more that are here, vocab words. So first one is a circuit. That's a path of connecting vertices with edges, that ends at the starting vertex. Uh-oh, hold on. Julia? Okay, circuit is a path that ends at the starting vertex. Very easy. Euler. All right. Well, Euler, there's a little thing in the beginning of the chapter about Euler, big time mathematician. Hey, I just said Bueller today, right? Rhymes. Euler. Euler path is a path that uses every edge, and it uses every edge exactly once. And then the last term just puts the last two together. A Euler circuit, then, is a Euler path that is a circuit. And a circuit is a path that ends at the starting point. So Euler circuit is a circuit that uses every edge. All right? Or it's a path that is a Euler path that ends at the starting point. All I did is play with the words a little bit in each case. All right, so then we have this thing. This is it. This is what's given. And I find it strange that I guess there is ways to go to B to E, and then there's a different path from B to E, apparently. I don't know if you saw that yesterday. I didn't do the homework, so I didn't see that if that was the case. So if we go to B to E, and then at some point go back to E to B, we can use a different path, not the same one. And that's, I don't know about important, but that's how we're going to be able to do these things. Are they a path, a circuit, a Euler path, a Euler circuit, or none of the above? Okay, and then what's a path? A path is just a connection from one vertex to the other without using more than one edge from yesterday. So A to E, boom. Okay, so good thing to do is mark it, dude. So draw your drawing on your homework, maybe in pen, and then do the paths in pencil and then erase because I got to use this drawing 5 times. So A to E goes that way, E to B goes that way, B to C goes that way. What is this simply? What is this from A to C? A simple what? Path. It's just a normal, everyday, average path. Nothing special about it at all. This is fun. Bueller. Oh, I can't do that. Gosh dog it. Now I got to use my eraser very carefully. Okay, sticking with this one. Should have you guys do it, but you can figure this out. B to E, E to D. I wish I was in bed right now. Anyone? You get it? Bed, tired, little nap. I'll be here all week. All right. Then D to A. Oh, this is exciting. A to E. Oh boy. Now E to B. What am I going to use? Am I going to use the one I used or the other one that's optional? The other one just to make it, so it's a different path. And then we're still on a path, I guess. I lost myself. E to B, and then B to C. So, is there anything special about that? So what is this? This is just a path, a weird one, from B to C. What's going on out there, silencer? This is quiet 1980s classroom. Next. A to D. Isn't this exciting? D to E. You can see it in your face. E to A to B, right? Yes, class. Or yes, Mr. Samus. B to E. E to B. B to C. So, is this a circuit, yes or no? So the path ends at its starting vertex. No. Is it a Euler path? And it uses everyone. Is it a Euler circuit? No, because it didn't end where it started. So this is a Euler path. Oh boy, we gotta wait. We already gotta. Oh boy. E to B. B to E. E to A to D. D to E. This is giving me a headache. And then what does it say? E to A. What happened? It's no path, right? Because we used, well, let me see. Wait, hold on. Yeah, it's not a path because I used an edge more than once. So a path that uses every, so it's none of the above, as far as what we're concerned, about using an edge more than once. Okay? So, sorry, that's strange. Now that I wrote that, I got to erase this. Boom, boom, boom. Boom, boom, boom. Then the last one. Now look at where we start and where we end. What is the possibility? It's possibly a circuit. What else it could be possibly, even with that little arm at the end? I don't think it could be a Euler circuit because I would need another path here, a different way of getting from C to B back and forth. Does anyone understand what I'm saying there? So Euler circuit has to use every edge once and end where it started. This little arm makes that impossible. We already got a hand up. Let's hold out. B to A, or B to E. Yeah, we all messed up. E to A to D, D to E, E back to B, which we have 2 options to do that. So is this a circuit, yes or no? We ended where we started. It's not a Euler circuit because I didn't use every edge in the whole scenario. Exciting stuff. All right, next exciting concept. Connected compared to disconnected. Very simple. The first graph, all of the vertices are connected. I can get from, any A through B, C, D, E, F, and I could get to all those points in any way I wanted to go, depending on what the, path is. But obviously the second one is I can't get from E to A. There's no way of jumping because they're not connected circuits, so therefore they're disconnected. I use the word circuit because it's in my head. These graphs, which we can talk about paths and all that. They're disconnected graphs of some sort of situation. What's interesting, or not, however you look at it, is this one disconnected? Well, the answer to that is yes, because this is not a what? It's not a vertex. Remember, now there is another word I'm going to use today that is actually a bridge, but I use this as an idea of a bridge in the real world. That one is maybe above the other one or something like that. So these two are disconnected as well because there is no vertex there for us to continue a path from one of the graphs to the other. Uh-oh. That was online. Somebody's phone's on. Okay, now, see, where are you going? You're strange in this class. I don't know, okay, all right, sit down. Okay, all right, now, last thing. Okay, so here we go. There's another walker. It's like gym class in here. All right. Now, I should have, during that story, had you take this down. Sorry about that. And then, is it connected or disconnected, and write the vertices. And then there's only one more thing after this, and I'll do a couple homework assignments for you, because I like you guys. I talk about you all the time. So, if you drew this, I think you could see that there are disconnections, because these are not what right here. You can't see that probably too much. These are not what? Here, and here. What are these not? Vertices. So this is really Mickey Mouse stuff. We're just exercising some words. So this is connected to this. I don't care which way we go. This, and this. Whereas this one, these are connected, but not connected to anything in the green. So those are called two different components of this one graph because they are not connected. So we have two separate components. I don't know, pretend it was that circuit board or whatever. Some of the circuits are not connected to other circuits. There's a text sound. This could be bad. All right. It was my text sound, which is Yoda's laugh. Oh, it's not. It's not her. Where? Let's all get along now. Okay, so A, B, C, D, E. I don't know what's going on. Shh, it doesn't have to be alphabetical. I think it's not obvious. I didn't move the screen. Oh, by the way, for the video, those are the components. I accidentally turned the video off. All right, let me unfreeze this. We're frozen on the screen, then move down. Okay, then the last thing, I know I said think of a bridge when we talk about disconnected, like one's above the other, but there actually is a term bridge in these graphs. I think it's obvious that that middle part you can consider a bridge because if you get rid of it, then you have two disconnected graphs. That's what a bridge does when you connect one piece of land to another over water so that we can get from one side to the other. So it's a very easy term. Okay? I don't know if I have that. Yeah, I do. Yeah. So I'll let you write that down for a second just for your note purposes. All right, that's enough. Okay, here we go. Now, I'm not going to draw this because I'm lazy, but you have to draw this in your homework. All right? So I pulled out 15 because it's kind of like 16, and then first hour I made a mistake and someone caught me on it. Good for them. And they were right. We already have a hand up. I just got through. You always get your hand up right when I'm in the middle. Just watch. Then you'll know how to do this homework assignment. Okay, now I'm telling you I'm being lazy. So what I'm going to do is I'm going to pretend, and you don't have to start your homework because it's going to go too fast here. Okay, identify all the edges that are bridges. Okay, so just identify what would be a bridge, do you think? A couple are pretty obvious. C to D. So this is what I'm going to do. You would have to just draw that real quick. It does say sketch the components if it was removed. So there's one of the answers you'd have to draw, right? What's another one? DF. Okay, just go real fast and draw that one. But don't do it right now. You do it when you do your homework. But this is what I messed up. There is another one. That is correct. Because if I got rid of this, who's got nothing? E is on an island all by itself. So actually DE is considered a bridge because then E would be disconnected from the graph. And it's only a point, but it's disconnected. So from D to E, that edge is considered a bridge because of E being by itself if that occurs. Okay, that's your answer, but your answer is making those three drawings. So I didn't give you time to do that. Hey. And then, I don't know, do you want me to do 17? What do you think? Okay, geez. All right, here we go. All right, Rust. Rusty. All right. Is it really? It's also the name of the horse in Seinfeld. All right. Anyone watch Seinfeld? Never mind. You know that one? The horse? Okay, never mind. All right. R to U. U to S. This is why you might want to make this drawing once and then lightly touch these and then erase them when you're done. S to T. Oh, and that's it. R to U, U to S, S to T. What is this? This is just a boring path. It's not a circuit. It's not a Euler path or Euler circuit. Okay, so then I get rid of that. I got to erase it. This is what I mean about making this drawing once and then do it. Or, gosh forbid, oh, you probably use your computer, so you can't write on the computer. Never mind. R to U, and then U back to R. That's a simple, basic idea of what a circuit is. Why is it not a Euler circuit? Because all of these weren't used. All of them have to be used in what's shown there for it to be a Euler circuit. Uh-oh, we got a painful face over there. R to Y. Where am I at? R to Y. Y to Y. Uh-oh, what happens after you do Y to Y? Y to R. No path. Not a path. So it's not any of those things. Holy crap, look at his last one. Ay. R to U, U to S, S to T. I don't want to go too fast. T to R. Okay. R to Y. Oh, I'm getting dizzy. Y to Y. And then Y to S. And then S to R. Is it a Euler circuit? Who didn't get used? We didn't use this U to R. Doesn't that stink? So it's an average, everyday, nothing ordinary circuit because you did end up where you started. That was fun.